Okay, on to 5.4, exponential functions with integration. We already looked at these earlier. Do you remember back in chapter 2 again when we were looking at chapter 5 stuff? We looked at the derivative of e to the x. It was just e to the x. So we learned before that e to the x is its own derivative. So what does that mean? You got it. It's its own integral. Okay, so we already know this. Look down below. If you integrate e to the x, you get e to the x. If this is something other than an x, we'll use u sub, but we're good at that. And we just get e to the u. Okay, so when you have something with e in it, I want you to look at its exponents first and see if that could be your u. So look at this one. I'm multiplying two things. Right away, I know that I'm going to need u sub because I cannot multiply them together. If this is my u, is that derivative in the problem? This will produce an x cubed, and there we go. So we're going to say u is negative x to the fourth, making du negative 4x cubed dx. Again, u sub is not leaving us with integration ever now. It's going to be all over the place. Okay, let's rewrite this. So we want e to the u. Look up above. The only thing we know how to integrate, guys, is e to the u. I've talked to you about this before, that we have that list of integral formulas. We can only integrate from that list. There is nowhere on the list that has this problem. So we need to make it look like e to the u. So we're going to replace negative x to the fourth with u. So I get e to the u. And look how nice this is. Negative 4x cubed dx is exactly right there, which is du. What does it say when we integrate e to the u? We get e to the u plus c, replace your u, and call it a day for this problem. Okay, now they're not all that easy, but they are going to be easier. Okay, looking at b. Now, what I said before is if the exponent is not u, replace it, but look at, that's just a scalar on that, and that's not going to help get rid of that. Remember before, though, when we had a problem like x to the fourth plus x cubed plus x all over x, because there was one term here, didn't we divide it into everything? Let's apply the same methodology. So let's go ahead and put e to the x into everything up top. Now, just as a reminder, if you have e to the 2x over e to the x, remember you subtract exponents, which will give you e to the x. So we're going to subtract these exponents. We're not using u sub right here. We're just trying to clean it up. U sub wasn't working. So we're going to get e to the x plus, now go to the next term. If e to the x goes into this term, they cancel and you just get 2. Now with the next term, we're going to have 1 over e to the x. But again, there's no rule for 1 over e to the x, but we can have an exponent. So I'm going to rewrite that as x to the, or e to the negative x dx. Okay, so now on to integrating. We know if we integrate e to the x, we get e to the x. Integrate 2, we get 2x. Now this is not e to the x, but what we would do is we're going to let this be our u, and the derivative of u is negative dx, so I just need a negative here to account for that. So negative e to the negative x plus c. Now, if you need to see that off to the side with the u sub, so let's take this part. This is the only part that we had trouble with because it wasn't e to the u. If I integrate this off to the side, e to the negative x dx, u is negative x, du is negative dx. So if I replace it, I get e to the u. Dx gets replaced with negative du. And you get negative e to the u, which is negative x plus c, which is exactly what I had. So it's doing u sub kind of like in your head. Because it was just a negative, it was easy for me to see. If you need to write it out, go for it. Okay, going on to the next one. What are we going to do here? Okay, this one for sure is a little more challenging. Let's see. Why don't you guys think about it? Okay, there's a lot of these going on, and a lot of them are just to the x or negative x, so that's not going to help. Look, if we look up above, let's see if I can move this up. Right here, this u had a derivative in the problem, and then everything else was gone. On this one, the exponent is just x or negative x. So when that happened, a lot of times, didn't we take the inside stuff of the denominator? Look at that derivative is e to the x minus e to the negative 2x, or I'm sorry, this derivative is e to the x minus e to the negative x, which is almost right there. So how about we rewrite this top by taking a 2, so we have e to the x minus e to the negative x. Okay, this is looking so much better now. That 2 was really throwing us off. So now let's let u be e to the x plus e to the negative x. So when in doubt, it's the stuff in the parentheses, right? And in the denominator. So e to the x plus e to the negative x is the denominator inside the parentheses. Du, go ahead and see if you can do that on your own. The derivative of e to the x is e to the x. E to the negative x is negative e to the negative x dx. And, oh, look at this beautiful problem. We have this bottom is u squared because there's u, so this gets replaced. So I have a u squared in the bottom. And then up top, I have e to the x minus e to the negative x dx, e to the x minus e to the negative x dx. So that's just du. Things are looking up. Okay, now on this one, we have to rewrite it as u to the negative 2 du. When you integrate, you're going to get u to the negative 1 over negative 1 plus c. I'm going to continue my answer over here. So that's negative 2 over u plus c, which is negative 2 over e to the x plus e to the negative x plus c. And we're done with letter C. Okay, take a look at example 2. Why did I write this one separately? Are you seeing it's a definite now? So we have to remember two things. We're going to replace the bounds with u, and we're not going to put x back into the problem. Okay, let's pretend we don't know this is from this section. What would we do? I see x's all over the place, so something has to be my u. If this is my u, the derivative is secant tangent, and there's not a secant tangent right here. If this is my u, the derivative is secant squared, and I don't see a secant squared. This cannot be u, because the derivative is just 2, and that doesn't knock out that stuff. So this is my u. Is that true? Sure, because the derivative is 2 secant 2x tangent 2x, which is right there. Okay, u is going to be secant of 2x. This is chain rule. The derivative of secant is secant tangent, and then the derivative of the inside stuff is 2 dx. So when I go to rewrite my integral, I'll do the bounds in a second. I'm going to replace my u first. This u is secant 2x, which is u. How about we get the pen? Okay, so we took care of all that. Now I have a secant 2x tangent 2x. Do you guys see that right here? What's over here that's not supposed to be? This 2. So let's divide both sides by 2 and get a 1/2 du. Oh, they sure do like us. Look how nice this is. Okay, going on from here, we have to change our bounds. We're going to take secant of 2. Remember what you're doing. These are x numbers right now because they go in for x. We want them to be u's. So I'm going to use this translation. U is secant of 2x. U is secant of 2. I need to replace this with x, which is pi over 3. Okay, I need secant of 2 pi over 3. Let's look to see where secant of 2 pi over 3 is on the unit circle. Okay, I hope you have this memorized, but if not, you could count by pi over 6 quickly. So pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which is right here, which is 2 pi over 3. Cosine at that value only goes over a little, so the ordered pair here is negative 1/2 root 3 over 2. Okay, secant is 1 over cosine. So if the cosine is negative 1/2, the secant is negative 2. Okay, U2. I need secant of 2 pi over 2. So that secant of pi, here's pi, cosine is negative 1. So I have 1/2. I'm integrating from negative 2 to negative 1 of e to the u du. My bounds are now u values. I'm not going back to x's, so it's 1/2. If I integrate e to the u, I get e to the u from negative 2 to negative 1. So now I have 1/2 e to the negative 1 minus e to the negative 2. Writing this a little nicer gives us 1/2 1 over e minus 1 over e squared. We could easily get common denominators, 1/2 e minus 1 over e squared. Okay. Okay, I threw in another definite integral so we can practice with this. What do you guys think u is? Pause it and try it on your own. Look, we have x's in multiple spots, right? This u is never x, and we know how to integrate e to the u, so if only this was u, so how about we let that be u? u is going to be negative x squared over 2. So then du is going to be negative x dx. I'm going to go over here to my integral. I'll switch the bounds out in a second. The first thing is replacing e to the u. So that is my u. The exponent is my u, like this part, right? So I'm going to rewrite this whole thing as e to the u. What's left? I have an x and a dx, which is right here. So I need to bring that negative over. So I'm going to get negative du. Do you guys notice after the u sub on all these that work is awesome? It's a lot easier. Okay, you look at the rule. The translation code is negative x squared over 2. My x is 0, so I'm going to have 0 here. u2, it's negative something squared over 2. Negative x squared over 2, x is root 2. So it's going to be negative root 2 squared over 2. Negative root 2 squared over 2, which is negative 1. Okay, so my bounds go from 0 to negative 1 now. If I integrate e to the u, I get e to the u from 0 to negative 1. That's going to be the opposite of e to the negative 1 minus e to the 0, which is going to give me negative 1 over e minus 1. And we're done. We could distribute the negative if we want, and it'd be 1 minus 1 over e. Right, that's a negative 1 over e. That's a positive 1. And ta-da, we have our answer. Okay, on to 3. Last one. Find the particular solution. That means they're going to give us an ordered pair to find our c that satisfies the initial condition. If we have the, is that the second? The second derivative, we have to get to the function. So first, we're going to integrate the second derivative to get the first derivative. Now we know how to integrate sine, that's negative cosine. How we know that is all I did was write cosine, I know that. The derivative of cosine is negative sine, so I needed a negative. Now this next part, e to the 2x, I don't know if you guys can see that it's 1/2 e to the 2x because of the u sub, so let's show that off to the side. If I integrate e to the 2x dx, u is going to be 2x and du is 2dx. I know that because I know how to integrate e to the u. Okay, e to the u is just e to the u, so I need this stuff to be my u. So then when I go ahead to write this out again, I get e to the u, done. Dx is 1/2 of du. So look, I'm going to get 1/2 e to the u, but u is 2x plus c. So a little aside note here. So I did that separate from the problem so that I can come over here because I knew how to integrate sine right away. Wasn't sure about that. So I took this part, did it off to the side, and now I can replace it with what I found the answer to be, which is 1/2 e to the 2x plus an overall c. This is f prime. I would love to find that c because they said a particular, and look right here, f prime of 0 is 1/2. So 1/2, f prime of 0, I'm going to sub 0 in. So I get 1/2. What's cosine of 0? Think of your unit circle. 0 is right here, and cosine is the x value, which is 1. So negative 1 plus 1/2 plus c. Right here, this is going to give me a negative 1/2. If I add it to the other side, 1/2 plus 1/2 is 1. C is 1, which means f prime of x is negative cosine x plus 1/2 e to the 2x plus 1. Why are we not done? Because they asked for a particular solution and all we found was f prime. Okay, now we need to go on. How are we going to get f from f prime? We're going to integrate. So f is found by integrating f prime. Okay, we know if we integrate cosine, it's going to be some kind of sine. Let's double check. What's a derivative of sine? Isn't it cosine? So I need to get rid of that negative by putting a negative in front. 1/2 is a scalar. We're integrating e to the 2x. Instead of doing u sub again, we already did it. We know it's 1/2 e to the 2x plus c. So another 1/2 e to the 2x. We're going to add the c on at the end. If I integrate this 1, I'm going to get an x plus c. There's f of x. Now they tell us that f of 0 is 1/4. So I can replace this with 1/4. F of 0 is found by subbing a 0 in for x. Look at this, 1/2 times 1/2 is 1/4. E to the 0 plus 0 plus c. Okay, we have 1/4. What sign of 0? That's 0. So I'm going to have 0 plus a 4th. So a 4th plus c is going to be what I have. So it doesn't... Oh, did you guys catch something? I don't believe I didn't catch it till now. We can't have two c's. This should have been c1. I'll just say I did that to see if you caught the mistake. Okay, there we go. So there's c1, c2. Making sure I didn't make any other silly mistakes. I'm sure you caught them if I did. Okay, going on. So then we know c2 is 0. Finally, f of x is, I'm going up here, and I'm going to replace c2 with 0. F of x is going to be negative sine x plus 1/4. Where'd the 1/4 come from? 1/2 times 1/2. E to the 2x plus x, and ta-da! We're good. That's it. That is it. Okay, see you guys.